Hi guys, it's Talha here again today. Today what we are going to discuss will be the two programs, will be the programs we did today at the university in the lab, and also so let's start from what we discussed in the class first, and then we went to the lab. So what we studied in the class first was about we finished our farmer chapter, and we started the latter one, which was user-defined functions part 2. And in that, today what we studied was about void functions. So one is in the category where you have there's a category where you have user-defined functions. So first you have predefined functions and you have user-defined functions. I've explained both of them in a previous video. So if you want to know what they are, you can just go to my previous videos, and there I have explained what are user-defined functions and what are predefined functions. Predefined functions. So inside your user-defined function. So in predefined functions are the functions which are pre-written, and user-defined functions, the functions which you write by yourself according to your needs. So you have inside. So these are two categories of functions, but inside the user-defined functions, the subcategory of user-defined function is your you have one is value returning function. One is value returning function, which returns you a value. At the end you put a return statement which returns the expression or the value to the function name or to the function itself. And then when you call the function, the function call statement replaces the your, so the function call statement replaces your returned value. And second, you have void functions. So inside, so the subcategory of so there are two types of user-defined functions. One is a value returning function, and one is void function. So today we are discussing void function. So what is the difference between a value returning function and a void function? In the value returning function, at the for example, this is the function, or this is the type, the data type, the type of the function, the type of the value this function is going to return. So for example, you write int here, you write the function name, then you write the parameters in the bracket, and you also have to mention the type of the parameters you are going to use in this function body. So you have function body, and at the end you have a return statement at the end, which returns certain value to the function name or to the function itself, and then it gets replaced by the function call statement you use in your function main. But what are void functions? So basically, void functions, the main difference between value returning function and void function is that void functions do not return values. So you don't use a return statement in void functions. They do not return a value. So as we studied earlier in the class, and I have told you guys in the videos as well, that the value returning function can be used at three places because they return a value. So you can either store this value or call this function and store it into a variable. So you can assign it. You can assign a value returning function to to an identifier or a variable. You can use it as an expression, so as a standalone expression, or you can use it in a cout statement, the output statement. But since void functions do not return a value, you cannot do any of these. They do not have any of these properties because they're not returning a certain value. So the question arises, then why should we use void functions instead of value returning functions? They both of the functions have almost the same task, but the only difference is the returning values. So let me first write the syntax of a void function. You're always going to start the function by writing void because it does not return a value. so it won't have any kind of a return data type. So you have void, then you have a function name, just like where when you define the value returning function, you have function name, and then you have parameters in the bracket, and like the value returning function, you can have these parameter parentheses empty, or you can write the formal parameters right here, and then you write the function body, and there is no return statement at the end. Or you can also do, what you can do is you can return an empty statement, or you can leave this return reserve word empty, so it knows that there's nothing to return. Basically, in void functions, you only use return, the function of return, when you use return with a void function. So basically what its main function is to just jump out of the function or to exit the function. It does not return any sort of value, it is just used to exit the function where necessary. So you have, this is the syntax, and so this is the syntax for defining a function. So how and the function prototype is the same. So what you do for the function prototype, you write the same, you write the heading of the function void, you have the function name, and you have again the parameters. And what are so what's the syntax for calling this void function? So you have uh, you call the function the same way as you call the value returning function. So you write the name of the function, and then you write the actual parameters of this function, which you want to be which the parameters you want them to get replaced with the formal parameters you have defined the functions with. So you can manipulate the data inside the function, and you can output the values based on the parameters you give as an actual parameters, which actually get replaced by the formal parameters and give you another or the value you want. So here the void functions. So what is the benefit? I mean, there's no way for me to tell that which of these functions is uh, which of these the void or the value returning function is a good function or a bad function, or there is no way for me to tell which one of them is good. But they both have different tasks. One returns you a value, and one does not return you a value. It's just a standalone statement. You cannot assign it to a variable, you cannot use it as an output. So for example, you call a function, for example, the function name is fact is the function name, and then you enter the parameters. You enter the parameters, for example, 1 and 2. So what it does when the compiler reads the function call statement, the controls shifts, just like the value returning function, the control shifts over to your the where the function is defined. So it's, conventionally the programmers define the function at the bottom of the program, after the main. So the control shifts over to the part where the function is defined, and of course you have to write the prototype before the main function, so the compiler knows that this function actually exists. So you have this function here where this function is defined. So what you do, so what the compiler does, it enters these formal parameters in the function, where the function is defined get replaced by the actual parameters you have entered here when you call the function, and then it evaluates, and if there's an output statement, it outputs the value, and then that's it. This function call statement does not get replaced by anything. It's just a standalone statement. So basically that is what a standalone statement means, that you cannot do anything with the statement instead of writing it just like you know directly inside your program. So it will not get replaced by anything. It will just output a value if you have entered if you have written an output statement in the function itself. If you have not, it's just going to evaluate and just going to start from the end and the and when it's done, either it's going to output, or if there is no output statement, the control will directly again shift over here, and the program is going to be executed onwards. So this is done. Now the next statement is going to be executed. So this was how the flow of control of the void functions work. Here, so today in the class, what we discussed was, and also I just said that you can leave the parameter list empty, and when you're going to call the function, you're also going to call the function and leave the parameter list empty. It doesn't, it won't give you an error or something, because you can have an empty parameter list. So today in the class, what we discussed was, sir told us to write two void functions. Uh, one was uh, one was for the factorial. So what we were supposed to do, we were supposed to write a function for the factorial in the at the bottom. So, and we had to take an input from the user inside the main function, and then we were supposed to call a function which shifts the control to the function itself. For example, I say void is a fact, as I stated before, and you enter here, you have a double, or you have a, sorry, you have a int variable name num, for example, num for number, and you have the whole algorithm here, and inside the function itself you have an output statements which returns you the flag, for example, which is going to be, you have a loop, which is the algorithm and all that, the loop, and then you have flag, and what it does is going to output it's going to output. So you call the function in the main, that is going to be fact, and you enter, for example, 7. So here is going to shift the control to the, and at the top you've written the function prototype. So it's going to shift when the compiler will read the function call statement. It will shift the control to your function body, where the function is defined, and here is going to calculate all the is going to calculate the factorial, and then in the function itself it's going to output the flag. It's going to it's going to output your factorial, and then after it's done, the control is going to be again shifted after the statement, after this function call statement. So so nothing will get replaced by this function call statement itself. It will just output you the factorial. And the second one, which the teacher did in the class, was about was the basic void function, where you have a function defined at the bottom. So you have, for example, as we did in the class, you have a double. So the teacher, what he did, he declared a function, or he defined a function void, and then function, I think this, yep, fun void. So this was the function name, and then in the parameter list he entered different variable or different data types for different variables to diverse, or to provide a variety of variables inside the parameter list. So one was int, for example, a, one was double, that was b. You had char for character. You have had a character c, and then for again int you had x. I think, yes, that was it. That was x. So after that, as he outputted, or he as an output, he wrote 4 statements, and for each output statement, and he ended the function. And for each output statements he wrote that the parameter of a, because and then so the parameter of a, he wrote that in the string, and then after that he outputted, or he wrote the expression a, b, c, in the same way x. So what was the function of this function? What was the function of this function? So the function of this function was to so when he called the function up here, he declared the prototype before the function main, and inside the function main, when he called the function, he wrote fun void, and then after that he included the parameter. First he declared the variables. And also one thing I forgot to mention in the video, that for example you have a parameter in the function which you want, which you are going to call which you're going to call later. So you have some parameters over here. So for example, this is an int variable a, and this is a double variable b. And so when you are going to call these functions, you have got to keep in mind that there's always a one-to-one correspondence between the actual parameters and your formal parameters. So what that means is the data type of the first actual parameter should match with the data type of your first formal parameter, and the data type of your second actual parameter should match with the data type of your second formal parameter. There's no way for a computer to know that what you want. So you have to keep in mind that you have to keep in mind the one-to-one correspondence of your actual and formal parameters. So what he did, he declared the variables after main, keeping in mind that there's one-to-one correspondence. So looking at the function, first he declared, as he declared the formal parameters in the function itself. He declared int, then he declared double, then char, the character, and then he declared the int again, that was x. So for example, this was d, e, f, and g, and then he assigned different types of values based on the data type. Then he called the function including these four parameters. Then these four parameters went the control shifted to the function body when he called this function using these parameters. The formal parameters in the function got replaced by these parameters, and now they had these values which we assigned to these uh, parameters, which we assigned to these variables. Now those a, b, c, and x had these values because they got replaced by these actual parameters. So this was about void functions. And also we have an assignment. So in the assignment, what we are supposed to do in the programming exercise, I think I explained yesterday as well. So you have to do question 1, 2, 3, and 4. It's pretty easy, except the question number 1, which is that we have to find the palindrome. We have to find whether the user. So first we have to prompt the user to enter a series of numbers, and then it's going to tell whether the number is palindrome or not. So what is a palindrome? For example, you have a number 1, 2, 3, 2, 1. So this number is a palindrome because if you consider the middle number, all of the numbers from 1 up till less than 1 and less than 10, all of the numbers up to 1 up till less than 10 are palindrome numbers. So what are palindrome numbers? If you omit the middle number, so when you start reading from the left side, 1, 2, 3, and then it should decrease. I mean it should go it should be read in an opposite way. Like there's 1, 2, 3, 3, and after 3 it should be 3, 2, 1. So it becomes opposite after reading the middle number. So the flow becomes opposite. The flow of reading becomes opposite after you read the middle numbers. So there's 1, 2, 3, and then it becomes opposite. The flow becomes opposite. So you have 3, 2, 1. So and if a number, for example, 1, 2, 3, 4, 5 is not a palindrome, because when you read up till here 1, 2, you reach to the middle number, and after the middle number, what is supposed to happen if this is a palindrome number, that the flow should become opposite and it should become 2, 1. but actually it becomes 4 or 5. So this is not a palindrome number. But all the numbers from 1 to 10 are palindrome numbers, and they are the exception because they're just a single number. But all the numbers greater than 10, what we are supposed to do, we are supposed to write a program, and then we are supposed to find whether a number is palindrome or not, and we have to output whether a number is palindrome or not, and also we have to output the number of palindrome number, I guess. I don't think we are supposed to, we're just supposed to output that a number is palindrome or not. Alright guys, that was it for today's video. I hope it helped. Thank you very much.